right, guys, Dustin here, and we are in Colorado continuing our long-range precision. Long-range precision's a little hard when it's 50-mile-an-hour winds like it is outside, right?
It gets difficult.
So we were visiting National Association of Gun Rights headquarters right here. Go check them out, subscribe, we'll leave a link and all that good stuff, because they are really fighting for your rights, no compromise. It was neat to hear all the stuff that they've been doing recently. Yeah. But anyhow, we brought Nick in here, and we've been using y'all's zero compromise optic. Which model's mine?
Yours is the 5-27.
5-27. It's really nice, and you actually designed the reticle there.
In that particular, scope,
Yeah, what was it called again?
That's the Impact 3X.
Impact 3X.
Actually, so it's a little spin-off from the original one that we had, which was the Impact 3. Mm-hmm. And some shooters just wanted some slight modifications, so we implemented a little bit of changes, and thus the X, we got rid of one thing and added a couple others.
Neat.
And so it's right now it is our top selling reticle.
So it's really neat. Well, we'll get into more reticles and stuff and later on, but we figured this would be a good opportunity since we can't go shut up and shoot outside. We're gonna learn a little bit here. Thanks for stopping by for today's video, guys, and a big thank you to our sponsor, Shields. Shields has all the outdoor equipment you're gonna need, from camping, hiking, biking, climbing, fishing, hunting, pew-pew, and even the Freedom Seeds. That's right, those premium brands, you can check it out there. Go to their website at shields.you-know-what, but we can't say it, and we thank them for making this video possible. Now let's get on with it. We know bullets drop at a distance, but there's a science to that in finding our dope. So say step one, a beginner at the range. What are you gonna teach them and how are you gonna walk them through?
One of the first things is we pretty much always have a 100-yard zero. Right, on our guns.
And that's an argument in itself.
Right, yeah, exactly. So a lot of hunters might, especially if you're hunting in Wyoming or Colorado, they might have a scope where you can't adjust the elevation in the windage turrets or anything like that. And so they might zero a couple inches high at 100, or they might zero for what they would expect for a 200 or even a 300-yard shot. Mm-hmm. Well, what we do with precision rifle shooting, we go with a 100-yard zero. I don't know of anybody that uses anything other than a 100-yard zero for this type of
solve.
So let me kind of explain why.
All right.
Okay, so generally what you know of as the bullet arc kind of profile, and your line of sight is one thing, right? Okay, so with this arc, how do we accommodate all this kind of good stuff? Well, you have your barrel is one height, and then your scope is sitting almost 2 inches above the bore. The reason that we go with a 100-yard zero is with this arc, we want this bullet to be rising up to your 100-yard point, and then it falls down. And whatever, it's going to keep falling, getting steeper and steeper and steeper. But everything in between the muzzle and any other target, if we need to shoot something else, we need to adjust up on our scope. If you're at 90 yards, it'll be a couple clicks up. If you're shooting at 50 yards, going to be a few clicks up.
Gotcha.
If you're shooting at 200 yards, you're dialing up on your scope. So you don't have to worry about, well, if it's in between here and here, I need to hold under. If it's between here and here, I have to hold over or dial under or dial over.
Everything's a holdover.
Everything is going to end up being a holdover or a dial up.
Makes sense. Because I'm curious, on some of the precision rifle matches, do they ever make them shoot something small up close just to mess with them?
I've shot lots of stages where we actually started out with like a 25-yard target, and it was a tiny little dot about this big.
Awesome.
But at 25 yards in your scope, it actually looks quite huge.
Oh, yeah.
But you need to understand the height of the scope over the bore, what is that distance, and how do you accommodate to hit something that small, that close.
That's great.
And then we stepped back to, I think it was like 40 yards, and same thing. And then we moved back all the way back to your 100-yard, and then it was hold center and send it.
But again,
but
always
everything
hold up.
Else we had to hold over for all those closer shots.
Interesting. That's neat.
Yep, absolutely. So that's why we use a 100-yard zero.
Okay.
Everything's holdovers or dial up.
So say we have our 100-yard zero established. What's steps 2?
Step 2. Okay, this is where we kind of look at what we did a little bit with the shooting, where we actually got the velocity on the ammo that you're shooting.
Very important.
That Hornady ammo.
Yes.
And we know that is shooting a 143 grain ELDX.
Right.
Do you remember what your velocity was on that?
It was 2,732 average.
And the BC on this particular bullet, we looked at the G7 BC number, which is a G7 ballistic coefficient was a 0.314.
All right, so say we have a teenager that knows bullets drop, but doesn't know, what do you mean by BC?
Okay, so here's different profiles of bullets, okay? So we can get into the G1 BC numbers as well, but most long-range shooting, we tend to go with the G7 numbers. And all that BC stands for is ballistic coefficient. It's simply a numerical value to describe how well that bullet flies through the air and resists wind deflection.
The slipperiness of a bullet, say.
Essentially.
Yeah,
right.
so if we're shooting a wad cutter or a shotgun slug, is like, what would that number be roughly?
That would be a very, very low number.
Okay, so low number's bad for long range.
Right, yeah.
All right.
Yeah, and so when you start comparing G1 versus G7, the G1 numbers tend to have a higher numerical value. It's just a different way to describe that particular. So we tend to go with this, and this is, the G7 is based off of the profile of the bullet, which much more accurately represents the modern bullets that we're shooting at long range. Okay, so we have a good G7 BC number for the bullet that you're shooting. We have good velocity. Next thing from there, we need to actually look at all of our atmospheric conditions that we're shooting in. The altitude, the temperature, a little bit of the humidity. Humidity has a very minor impact, but it's still a variable that we should account for.
Sure.
Okay, all of that stuff that makes up the air that the bullet is actually going to fly through.
Okay.
Okay, we need to look at all that. And so one of the handy little tools to figure out what all that stuff is, other than on your phone pulling up the weather channel or whatever airport station, is using one of these Kestrel weather meter. And this will tell you all of those atmospheric conditions.
Right, without an internet connection.
Without an internet connection. And so that this particular Kestrel has a ballistic program integrated into it. And so what's handy about that is this actually pulls in all of the real-time data from the atmospherics, as well as computes your ballistic change due to the atmospheric conditions.
Because they even work, they have a compass in them, so you point it like, oh, the wind's coming from that direction, but I'm shooting that direction. It's going to put that in there.
Correct. You can adjust all of that, and it'll tell you mathematically what you need to do. But we start out with your velocity and your ballistic coefficient of your bullet. And then we need to know all of those other variables.
Gotcha.
Okay. And so on my phone, if I just want something quick, I have a certain program that I use on my phone. Hornady makes an outstanding app, that you can download onto your phone, and you can mess with all that and put in all those variables.
That's what I was playing with yesterday. It was pretty neat.
Right. And so when we look at the atmospheric conditions, one of the most important numbers that we refer to is DA, stands for density altitude. Notice the key word here is density.
Okay.
It's talking about air density and then the altitude. So where do we get this? So all of this density altitude is essentially taking into account the temperature of the air, the altitude that you're already at, whether that's at sea level or up here around 5,500 foot altitude. It's taking into account the humidity, all of this stuff, and it's going to roll it into one number. Okay. Another variable that you want to put into here is your barometric pressure. Okay. So if you have a storm system either coming into the area or moving out of the area, that barometric pressure is going to change based on those weather systems.
And that will affect the flight of your bullet.
Exactly. So right now we have a lot of wind going on out there that's telling me that there's a change going on with the atmospherics. So we would notice a barometric pressure change.
So my holds from 800 yards yesterday might be different today.
Might be slightly different today, based on all that stuff. All of this basically gets plugged into one particular numerical value that we can work with.
So as a shooter, you know, looking at all these conditions, if you could pick the perfect, now I know it's just changes no matter what, but the perfect weather bubble, you know, say, you know, the temperature needs to be 68 degrees and altitude, I want to shoot at, what would that be? Or is that something you've thought about?
Yeah. So if we want to look at bullet flight, right? So if the bullet is
minimum effect on it,
flying through the air, we would want warm air.
Okay.
Because warm air means that the air molecules are moving faster, they're spreading out more, so it's going to be less air in a given volume,
so
right? Because it's spreading out more. We want warm air. We want high altitude, because that also means fewer air molecules. So all of that would provide a less dense air for that bullet to fly through. That would mean less drop at distance that we have to worry about, and also less wind effect because it's getting there much more efficiently.
Of course, no wind, Neat.
So if you want to look at what would be the best, right? And so for like aviators, for them, if you're high, heavy, and hot, those are not good conditions, especially as a rotor wing pilot, right? Because then there's less air for the rotors to actually work on. Those are bad conditions. We want good, thick air.
Neat.
Yeah.
Okay.
So anyway.
So I'm thinking that is like mountains of Afghanistan and stuff then? Is that prime sniping conditions?
That's excellent for military snipers. Yep, good, thin, hot air is actually fairly decent. Yeah, and even higher humidity means better bullet travel through the air as well, because with higher humidity, the air is actually less dense.
Okay.
Yeah, it's just backwards with what most people would think.
I thought humid air molecules because I'm sweating and the air is, we have to swim through it.
The water molecules actually make things kind of expand a little bit for that volume of air. They take up more space, which negates other stuff. So it's actually less dense air the higher the humidity. Okay, so right now all that we have is computed data.
Right.
Okay, and so that to me is your starting point. Now we need to verify, does that data actually correlate with what we see at distance?
So for a new shooter, I'll interject here, if you bought your Walmart gun and you sighted it in at 100 yards and you ran the app on your phone with the data from the ammunition box, yes, I roll, I'm expecting that. You're not ready to shoot 1,000 yards, bro.
No. The velocity that they're going to give you on that box of ammo was for a test barrel type condition, or whatever that barrel length was. And the rifle that you have off the rack might be a different barrel length, might be a rougher bore, could be a smoother bore.
Yeah. The same gun off the same, it's very unique.
Very, very unique, yes.
Even the same bullets.
So the velocity might be close, but it's not going to be the most accurate.
Right. It's at least something,
rifle.
But you can't trust it.
Right, it could be a base starting point, but then you're going to need to refine and verify. With that, what we actually need to do then is have you start shooting, and preferably in 100-yard increments. We already know 100-yard 0 is good to go. Now we'll step it out to 200 yards, and we have an idea about exactly what it should be. It's probably not going to be very different from computed. Where we're mostly going to start to notice a difference is about 600 or 700 yards. That's when you're going to start to see maybe a 1/10 difference, either higher or lower. Okay. And so what we tend to prefer to do is around that 600-yard mark is in our ballistics profile, maybe tune up the velocity just a touch. Even though we have really good numbers, maybe a 5 feet per second, 10 feet per second might make a little bit of a difference at that distance.
Yeah, because you could have that much of a variable in load anyway.
Right, exactly. And then beyond that, out to near the transonic, but still supersonic range, is where we want to true up the actual ballistic coefficient for the bullet on that day, those conditions and everything, because all your atmospheric conditions can have an effect on the BC of the bullet. Even your rifling twist rate can have an effect on the BC of the bullet.
And that's why it's called DOPE. So if you heard a DOPE chart, it's...
So DOPE is essentially an acronym. Stands for data on previous engagements. So how do you get DOPE if you've never shot before, because you don't have that previous engagement? So what we like to do is actually go shoot at distance and make sure that the numbers that we have in our ballistics program actually align with what we see at actual distance. And then we have a much better firing solution for future stuff. Okay, especially if you're going to go from Colorado down to Texas, and there's a lot of shooting ranges in Texas, but your atmospheric conditions are going to be a lot different.
Yeah.
Right. But you'll have a base starting point. Well, I know that these numbers are working in these conditions, and now we're at less altitude, but it could be hotter.
Right.
Okay, and that could offset everything at that point.
Yes.
Because you're lower altitude, but you're hotter conditions, so things could maybe balance out a little bit.
So say that we have our dope and we're ready to reach out. What are some of those numbers going to look like?
Okay, all right, so you're 100 yards, you're zero.
Zero,
Right, everything is good to go. 200 yards. For your data, what we gathered, you're right at the 0.4 mil, right? Okay, your 300 yards was a 1.1 mil.
Yep.
Your 400, I believe, was right at a 2.0, going off the top of my head, mil.
Okay, so some of these guys are looking at this saying, wait, that's not an inch, what's a mil?
Right, okay.
Right.
So you're talking minutes of angle versus mil. Right? Okay, so mils actually stands for mil radian. And then most hunters are familiar with what they call MOA.
It's the easiest conversion from an inch.
And it's a minute of angle. Both of these go off of this concept here of an angle. Okay, it's nothing more than an angular unit of measure, this little thing here. They're different. Though, okay? 1 MOA is actually equal to 1.047 inches at 100 yards.
Right.
So most people say, well, that's pretty much an inch.
Right.
Who's going to worry about 0.047 of an inch? Nobody really worries about that. So generally, we round that off to 1 minute is close to 1 inch, right? Well, 1 mil, a mil radian, 1 mil, that is equal to 3.6 inches at 100 yards. So quite a bit larger number then, right? So here you could go to math and conversions and how many minutes per mils and all that kind of jazz. All that we really need to understand is this 1 mil is an angular unit of measure. So all of this means is that if we're shooting, if this here is 1 mil, and this is 100 yards, well, this 1 mil is going to be the same at 200 yards. 1 mil is a 1 mil at 300 yards. But this right here is 3.6 inches.
Right.
Well, at 200 yards, what's it going to be? 7.2 inches. Get all the way out to 1,000 yards, what do we have? We have 36 inches.
And so once you have that, optic that we were using and with that reticle, you don't even think in inches anymore. Everything is just like, it's on the calculator. It's like, try this many mils, and your spotters are using the same angle of measurement. So they're just like, hold 0.5 mils. Nobody says hold half a foot. And it's just, it's all mils now.
No, and what's really handy about the mils version is that everything is base 10. You have 0.1, 0.2, 0.3, 0.4, 0.5 out to 1 mil. And then beyond that, you have 1.1, 1.2, 1.3, 1.4, 1.5, et cetera, et cetera, et cetera. So everything is base 10. It's easy to count, it's easy to think in, and the numbers are actually smaller to dial, as opposed to I need 26.75 minutes. Right now we're talking you need 4.6.
So just like we talked about 100-yard zero becoming standard, is the long-range community kind of settled on mils more?
It depends on which long-range community you're talking about. Your F-class shooters tend to still work with minutes of angle.
Right, but they're not.
They do a
different thing.
The more tactical competition, PRS, NRL
That's
type
what I'm
competitors,
leaning towards, right?
Most everybody is converted over to mils.
Good to know.
Most. There's still a few MOA shooters that are out there, and that's comfortable for them. They're happy with it, no big deal. But probably 8%, 99%.
That's a really high percentage.
Are running in the mils. It's easier numbers to work with all the way around.
Well, cool deal.
Yep. So, so these are kind of some of your base numbers, and we'll end up building all the way out to beyond 1,000 yards, right? And then from there, you got that written down in a logbook, or it's into your ballistic profile on your gun, and it's pretty easy to reference. And so one of the things that actually is going to affect a lot of this, as we touched on earlier, is your air density of things, right? So if we think about air density, altitude, whether you're at sea level or if you're on the top of Mount Everest, essentially all that we think of is everything being nothing more than a column of air, where this is sea level, and this we'll just say is 10,000 feet. Well, down here at sea level, we have all this air that's kind of pushing down, pushing down, pushing down. All this air down here is fairly thick. You have a lot of air molecules down here, right? So fairly thick air. But as you get up to altitude, a lot less air at altitude, right? And so what is air composed of? Oxygen, carbon dioxide, nitrogen, water vapor, all that kind of stuff. It goes on in there, right? So again, with our density altitude number, we're putting a numerical value to describe, are we under these conditions? Are we under these conditions? Or are we under these conditions?
Right.
What's going on? What is this most similar to? How thick is that air as it presses down on there? Because that's really all that is a column of air, and how much air stuff, oxygen, carbon dioxide, nitrogen, water vapor, is there in that. So for example, the altitude, the base altitude, not density altitude, base altitude where we are is 5,500 feet.
Right.
ASL, above sea level, right? Okay, well, with our computed number for a DA was actually very close to 7,500 feet.
Okay.
So this is our actual base altitude, but due to the temperature, humidity, all that stuff that was going on, it was like we're actually another 2,000 feet higher altitude up here. Okay.
All right, now it's coming together.
Yep. So that's really the usefulness of a density altitude number, but you don't need that. You can use all those other numbers and do this exact same thing.
But it's a nice point of reference.
Exactly.
But, this density altitude, that DA was near this DA, even though the temperature and the elevation are different, it now matches.
Yes, exactly. Awesome. And so what you'll notice when you start paying attention to the density altitude, it's going to be one number in the morning. As it warms up, it's going to change. Right? So it's just like you're gaining altitude, because those air molecules starting to warm up, they're starting to spread out a little bit more. You're gaining altitude more or less.
We didn't want to take a 6.5 out 50 mile an hour wind, but say it was more manageable. How do you teach wind holds?
Okay, and wind is essentially the great equalizer for shooters out there, right? Who can manage the wind the best? Who can spot their miss if they do miss, and then make a follow-up correction to that. Wind can be a very complicated thing. Okay, so if you think of a clock, little clock face, here you got your 12, 3, 6, and your 9 o'clock. If you have your wind blowing from either the 3 o'clock or the 9 o'clock position, we call that a full value wind. It is putting the maximum effect. Let me back up a little bit. We always consider the direction that we're shooting to be 12 o'clock.
Of course.
Okay, so we're shooting this direction here. So any wind blowing from the 3 or the 9 is going to have the maximum effect pushing that bullet off course, either to the left or to the right. Okay. Well, if we have a wind blowing from either the 12 or the 6 o'clock, it essentially has zero effect on the lateral dispersion of that bullet left or right. Okay, it can have a minor effect, especially close range, very, very minor effect on bullet drop. It's not really going to have much.
Because it's riding with it or against it.
However, as you start to really push the distances, then a headwind can start to slow down the bullet a little bit more. You might have to add a little bit extra elevation. But again, we don't really worry about that a whole lot.
What range would you say that matters? Of course, wind speed matters too, but...
Yeah, that's really, in my opinion, going to have the most effect as you start to get beyond about 1,000 yards.
That's what I was thinking.
Effect. Yep. So mostly we're concerned with something from the side. So you can have your 1 o'clock or your 2 o'clock winds as well. Now that's obviously, if it's blowing this direction, it's going to have some sort of effect, pushing that bullet to the left of your course of fire, okay? Or from the 2 is going to have a bit more effect. Now, where would you think you would have half the effect of the 3 o'clock to the 12 o'clock? Where would the half value wind?
I would think in between the 2 of them.
You'd think at about the 45 direction. Yeah, that's not the case, actually. Yeah, it's actually a little bit more complicated than that. So one of the easiest diagrams to draw up, and I saw this in a book years ago, I think it's actually called The Wind Book. I think that's correct. I forget the author's name, but if you essentially just make this an L shape, if this is your full value wind, where is half of that? Half of that would be about here, half of that 100%.
Okay.
That's your 1 o'clock.
Interesting.
Wind is essentially your half value. If the wind is from the 2 o'clock, that's real close to about a 90% wind value.
Okay.
So from your 3 o'clock wind, now let's look at your cartridge that you're shooting. 143 grain ELDX bullet from Hornady, 2,732 feet per second.
Okay.
I haven't gone in and manipulated to look at the numbers exactly, but based off of my experience shooting that same cartridge, similar bullets, you're going to have what we would call a 6 mile per hour gun. Okay.
Okay.
So that's a 6 mile per hour gun. So, okay, so you just looked at me kind of funny, like, well, what does that mean?
That's new to me.
What does that mean? Okay, here's how we look at this as an easy way to manage the wind and make, kind of off the top of our head, wind corrections. Okay. If your wind from either the 3 or the 9 o'clock is exactly a 6 mile per hour wind, you just happen to be lucky and it's right at 6 miles per hour. We look at our drops from 100, 200, 3, 4, 5, 6, out to about 700 yards.
Okay.
This works out really, really well. A 6 mile an hour wind, we just use these numbers here. You're going to move your bullet about 0.2 of a mil. At 300 yards, it's going to be about 0.3. 400, about 0.4.
Okay.
0.5. 0.6, 0.7.
Well, that is handy.
Those are going to be real close to a wind correction given a 6 mile per hour full value wind for those distances. Okay, well that's also really nice and handy. How about a 1 o'clock wind? If it's 6 miles per hour and it's right at the 1 o'clock, well, now we can have these.
Awesome.
So this is going to then end up being a 0.2 mil wind hold if we know that wind is right at the 1 o'clock value.
That's a really handy tip.
How about a 12 mile per hour wind? If we can measure with our Kestrel, we know that it's 12 miles per hour, full value, we can double those numbers.
Awesome.
Okay, so that's a real quick mathematical way that we can manage the wind in our head on the fly as we're actually shooting at distance.
So I know this may be a little more in depth than we want to get into, but how do I find out I have a 6 mile per hour gun?
Look at your ballistics program, and you go, let's try 5 miles per hour.
Until
then we
we
look
get
at
this?
the drops until we notice that these numbers here all
Match
line up.
their mils.
And it's going to be really close to 6 mile per hour wind value.
That is a cool tip.
So one other thing with this then, are we shooting in the flatland all the time?
No.
No. Sometimes we might shoot in the mountains.
Yeah, right.
Okay. All right. How about if we're taking a 1,000, 1,200 yard shot? Is that bullet flying right close to the ground as if we're prone shooting 100 yards? No, it's rising up in the air quite a bit, right? Okay, here's where we talk about something that was defined as wind gradient. So if this is your ground level, and you imagine the wind is blowing at any given velocity, it could be 4 mile an hour, 20, 50 miles per hour wind, right? Well, as the wind is real close to ground level, you have grass, you have trees. What's that going to have an effect on the wind? It's going to slow it down a little bit at ground level. Have you ever been in a really windy kind of day and you laid flat on the ground? It feels like it's not quite as windy, but you stand up and now it feels like it's blowing. Well, so wind gradient is this concept that the higher you get above ground level, the wind is actually a higher velocity than it is closer to the ground because of the friction effect that the ground has on that wind. Again, wind is nothing more than air in motion. That oxygen, carbon dioxide, water vapor, all of that is being dragged by the ground contact friction. And so the air molecules that are in direct contact with the ground are in contact with the air molecules above them. They're in contact with the air molecules above them. It slows things down the closer we get to ground level. So if we're shooting at distance,
we're lobbing them things 30 feet in the air.
Now we can actually have more effect of the wind based on the height the bullet is getting above the ground. Or if we're shooting in mountainous terrain.
Right, and the ground is now lower.
And either you're on a mountain peak shooting to another mountain peak, and if the wind is really blowing and it's going through a canyon, it's going to be a lot faster going through that canyon than maybe where you are actually measuring with your Kestrel. Yeah, so there's a whole bunch of stuff with the wind that we have to
all the way downrange.
That's right. Yep. And one of the things is we can only measure the wind at our location. Okay.
But we can look.
But we can look downrange. We can see the effect of the mirage in our glass, in our spotting scope, even with our binoculars, and we can get an idea of about how fast that wind is blowing based off of the mirage. So if we're looking through our binocular and the mirage kind of just looks like heat waves coming up off of a hot road, and they're coming straight up, but we can tell the wind is blowing a little bit, that would indicate that to me that the wind is either directly in our face or directly behind us.
Gotcha.
But if we notice, then when we're looking through our spotting scope or our rifle scope, the heat waves or something like that, that would indicate that the wind is definitely from the left for that particular moment anyway. And based off of the mirage angle, we can also get an idea about how fast the wind is blowing. Because up to about 18 miles per hour, you're going to start to see that mirage. Get any more than that, and it's not going to look like much mirage at all because it's all getting blown straight to the side, or it kind of lays down. So looking at the mirage can be one way that we pick up on how strong the wind is as well as the wind direction. Okay, so there's those things that we get to use for wind indicators as well. And if you don't have mirage that you can pick up in your optics, a lot of people just look at the vegetation. How is the vegetation reacting? Is the grass blowing? Are the tree leaves rustling? Are the trees swaying? If it's a small tree and it's kind of swaying, that would give you an idea that the wind is more than a 5-mile-an-hour wind. It's enough to move the trees. But if your large trees aren't really swaying too much, well, now you're probably looking maybe a 12 to 15-mile-an-hour wind. But if those large trees full of leaves are really moving, you got some pretty serious wind that you're looking at. You have a target, whatever that target may be, whatever distance it may be. One of the biggest things that I can emphasize to a shooter, especially a competition type of thing, is if your crosshairs are centered on that target, you take your shot and you see an impact off to a side, your reticle is nothing more than a ruler within your scope. Right? Measure with your reticle. Where is it from the center to where your actual impact is, and then just take and drag that point of your reticle over onto the center of the target and take your follow-up shot as fast as you can before that wind either changes direction or velocity. You have a much higher chance of impacting your target at that time.
Good tip. Instead of like, oh, well, it was over there, but I'm gonna wait for it to die down a little. Well, now you don't have a point of reference that's accurate anymore.
That's exactly right. So make your follow-up shot as fast as you can after you see the splash, if you saw the splash of your first shot.
So I noticed, we were talking about holding off on a reticle and that. Do we ever dial for wind or?
Yes, great question. And it is all circumstance dependent. Type of thing. Okay.
Like it'd have to be really steady if you want to dial, right?
Yes, or maybe you're just in a relaxed setting and you're shooting at the same distance and the wind is fairly constant, blowing whatever. Maybe at that time, so you're not always holding into the wind one direction or another. Maybe you want to go ahead and dial a correction onto your scope at that time so you can use your center crosshair to keep shooting that target.
Maybe target dependent.
Right, exactly. And so generally, a good rule is most shooters are dialing the elevation on their scope.
Right.
So they might have a target at 552 yards instead of trying to hold with their reticle as well as hold for wind left and right. It's much easier to dial the correction for the elevation onto your elevation turret of your scope. So now you're at the main horizontal bar of your reticle, and then you hold the crosshair goes into the wind, whatever you think that it might be. So earlier we were talking about a 6 mile per hour gun.
Right.
If the wind is full value, 6 miles per hour, we're shooting at 700 yards, we need 7/10 of a mil wind correction. So if it was from the right, we'd hold 7/10 into the wind. So we'd be looking at the 7/10 indication on the left side of center of the reticle.
Good stuff.
Okay. Yep. Other situations, a lot of what we do is we might have moving target situation where you actually have a target. It's generally on something similar to railroad tracks.
That sounds fun.
And it moves back and forth left to right. Well, if you're a windy day, how do you manage that target moving left and right and the wind is always from one direction? Well, it's easiest then if we make a good wind call. It's a 15 miles per hour wind. I'm going to go ahead and dial that onto my scope. I'm going to lock that down so I know it doesn't get bumped. I'm going to dial my elevation for that target. Now whether that target is moving left or right, I have the same lead value for the left or the right shot.
Right.
I don't need to manage, well, the wind is from the right and it's moving to the right, and how do I don't have to worry about that.
Good, just to simplify things a little more.
Yep.
Because I didn't even thought about moving targets yet, but now that sounds like a fun challenge.
Oh, they're awesome. They're a lot of fun.
Cool.
Yeah, especially when you have a coyote-shaped target and it's moving fairly fast. Those are fun. Those
That's
are
crazy.
Fun. Those
All
are
right.
fun shots.
So hopefully we can have some more fun soon. And so make sure you check out this whole precision rifle series and enjoy your free sniper intro to external ballistics class. I mean, yeah, you just gave away a free class. But yeah, you're lucky. Thanks for watching. Okay, I love you. Bye-bye.